We are going to talk about the next three questions in the 2018 AP Stat FRQs. We're going to start with number 3, 4, and 5, and then we'll take 6 on in a different video. These were relatively short questions. Surprisingly, all 3 of them were relatively short and didn't require a whole lot of effort. The only one that was somewhat long was question 4, and this was sort of a panic question, or a phantom question. You could also do panic there as well, but we'll get to that in a minute. First thing we're going to do is we're going to talk about question number 3. This was a probability question, and so in terms of what did I needed to know, I needed to know basic probability. Tree diagrams were helpful here, and you can see that in part A. I also need to know conditional probability and the general addition rule. So those are things you can look up if you're not sure where I pull some of this stuff from. Part A says, what's the probability of selecting a child born in the region that is left-handed? So I needed to know, given all conditions, what's the probability of just being left-handed? This should have reminded you of several of those tree diagram questions. The question with the forbidden material, or Shmuel trying to catch his plane. All those things were things that we did in chapter 15. You can look at it here. I made a diagram basically talking about being, if it was multiple births or it was from single births, and then it was from left-handed or right-handed. Each of these things were complementary, and so they told you one of the probabilities, so I could have figured out all of the probabilities if I had needed to in that situation. I wrote down each of the ones they gave me and kind of written, if I needed it, I found it. If I didn't need it, I left it blank, like for right-handed. I didn't need that probability, so I left it blank. The rule that we're really following is this one right here. The probability of being left-handed would be the probability of being left-handed given that you're from multiple births, or in this case, plus the probability of being left-handed given that you were from a single birth. In this case, I needed to find those two probabilities and then add them together. And so we multiplied those two values together to get 0.0077, and then these two values to get 0.10615. Adding them together gives me the total probability of being left-handed because or indicates the addition rule. And so when we added them up, we got 11.3 or 11.4% of the people are left-handed. In order to get full credit for this question, I really needed to show my method of probability. A tree diagram was definitely one of the accepted rules. You could have used a few things here to get that probability correct. Let's see, in question 3, to get full credit for just part A, you needed to be able to talk about your method of probability. How did you calculate the probability? And get the correct value, right? So if you used, if you used a formula specifically, or if you used a tree diagram, or some other appropriate strategy that allowed you to get those probabilities, just purely mathematically, then that would have been acceptable tool. But you had to have work and the correct answer to get the full credit for part A. For part B, this is a little quicker. It asks, what's the probability that a randomly selected child is born in the region is from multiple births, given that they were left-handed? Well, you had to have part A. So if you made a mistake in part A, that error can transfer through without any negative impact in your score. I used the probability of being left-handed here, and I wrote the formula down for conditional probability. And so I said the probability of being left-handed and multiple births divided by a probability of being left-handed, and then I just simply plugged in the values that we were given to get the correct value of 0.0763. In order to get credit for part B, you had to show work for the numerator and the denominator and get those two parts correct. So you needed to basically have this piece, and this piece to get full credit. If you left one of those pieces out, you probably would have gotten only partial credit. Part C, it says a sample of 20 children, and you wanted to know that at least 3 of them were left-handed. This should have been a big kind of red light. This is binomial. You had a specific number of trials. You had a specific probability of success. It was either left-handed or not, right? All of those things played into part of using binomial. I could not have used normal CDF in this example. My sample size was not large enough. When you do the n times p and n times q to try to see if it can be approximated by normality, right? You had to have at least 10 successes and 10 failures. You definitely don't even come close to getting that right. So If you chose to use normal CDF here, you would have gotten the answer wrong. In order to get full credit for part C, I had to label quite a few things. There's 5 things that I needed to make sure to get right. Number 1, I had to identify that it was a binomial distribution. Number 2, I had to specify what N and what P was, right? So N was 20 and P was 0.11385, or whatever you used, whatever you got in the previous answer. If that transfers on through, then that would have been, you would have gotten credit for that. Okay. 3, I had to use the correct endpoint for probability. So depending on how you did it, right? I should have did was I wanted to find the X value that's greater than or equal to 3. So that's one way of showing it. I could have also said I'm using a binomial CDF and my endpoint was 2, but I'm subtracting it from 1. You could have gotten credit doing it that way as well. Number 4, you indicate the direction of the probability that it was a greater than or at least. That's where I've gotten it here. I think I could have gotten credit for it by writing it out in that method as well. But I think I wanted to make sure I put it this way just to show that what I'm doing. I also put it down like this. That would have given me credit as well. And then 5, obviously, I had to get a correct answer that followed through, it was consistent with my previous answers. So if your probability of being left-handed was a little wrong, as long as it followed through and you got that correct probability based on your information, you would have gotten credit for it here. But the correct answer was 0.402. If you did all of those things, full credit. Not a lot of explaining here. There's a lot of probability questions where the work is enough to show you what you got right, but you're writing the formulas, you're writing on what you plugged into it, and then getting the correct answers down. Okay, that's question 3. Let's go on to question 4. Question 4, this is the one that you hope to get. This is the one that we really all want to see. This is our significance test question. This is a quantitative question. I wrote that down first thing, and then I wrote down that it was I circled random, and by the time I got to the end of the question, I knew this was going to be a 2-sample t-test. We were looking at we didn't have any kind of standard deviation for a population or anything like that, so no z involved. In this example, I just went straight into writing out my phantom part of it, and I wrote down my null hypothesis, which was I used S and N to indicate standard and nu. If you didn't indicate with some kind of symbols that were consistent with the way they wrote things, you had to kind of define that off to the side. If you used A and B, then you needed to say A was new, or A was standard and B was new, however you wanted to do it. But make sure that you defined it in a way that was clear to the reader which one was which. You couldn't have done that just randomly. To get credit for question 4, you had to really go through 4 parts. It's 4 steps, 3 sections. That's kind of hard. If you read this solution guide, I had to read it 3 times to make sure how are they grading it. So I think if you went through Phantom like we're used to doing, I think you're going to get your bases covered. That's kind of why we learned it that way. So I'm just going to run through Phantom and kind of make sure that we all got all that right. So number 1, the null hypothesis was that mu s was equal to mu n, and the alternative was that mu s is greater than mu n, or that mu n is less than mu s, right? The nu was less than the standard. However you wanted to write it, if you flipped it around, you're still fine. Just make sure that the nu was supposed to be less than the standard. For your assumptions and conditions, the 2 they were looking for, right? This is step 2. You had to identify the name of the test, so 2-sample t-test, and check 2 specific assumptions. Number 1, you had to identify that this was a random assignment of treatments, of subjects to treatments, and which was stated in the problem, so it's given to you, and that they are normally distributed. And we know that they're normal because the sample size is large enough, right? I said it's larger than 40. If you said they are sufficiently large, it's also going to get you full credit. Okay? If you did both of those things, you got part 2 correct. Part 3, or step 3, is all the mechanics, all the numbers. Did you get those right? My t-score was 7.13. My p-value was essentially 0. It was 8.36 times 10 to the negative 12. Approximately 0, right? That's insanely small. I wrote down my degree of freedom as well, 207.18. I don't think that was absolutely necessary. But I would write it down just to be safe. Most of the time it's not required. If you wrote the correct p-value test statistic, you're fine. Here again, this is one of the things where it's kind of difficult to figure out exactly what they're looking for. There's a lot of information there. Anyway, that's step 3. Step 4 was to write out my last conclusion, or the bottom part they're looking for was the conclusion. I had to do a couple things. Number one, I had to make the correct decision. I didn't have to say reject or fail to reject, but I had to tell you that our evidence suggested that the new treatment recovery time was less than the standard treatment recovery time. That's what I needed to do. I needed to say that my p-value is really small, and that's why I did it. I went ahead and said we reject our null in favor of alternative because our p-value is less than any traditional alpha level. It's super small. Our evidence suggests that the recovery time is less with the new treatment on average. Okay. In order to get this is part 4 correct, I needed to state a few things. Okay. I needed to state it in context. I needed to state that the recovery time for the new treatment was less, and that I based that decision on my p-value, that it was a really small p-value. If you did those 3 things, then you're good to go. If you did all of those things, then you're going to get full credit. Here again, this was quite difficult to score. You could also approach this with a confidence interval, and they put that into the conclusion or the notes on this. I'll let you look at that. I don't suspect very many of you would have done that. If it had been a not equal to a alternative, I might have thought about doing a confidence interval. But anytime it's less than or greater than, I don't want to do a confidence interval because it requires me to do a lot more explanation. Because you're looking at two-sided things compared to not two-sided things, right? Confidence intervals are always two-sided. Significance tests that are not equal to are two-sided. So they work together. They work really well together. But if it's a greater than or less than, try to stay away from confidence interval methods of solution. Okay? If you got all those right, you get a 4. If not, check out the key. It's really complicated. I think most of us, if you didn't get that right, go back in, fill in which part you missed, and we'll be solid. Number 5. I think for most part, A and B on this question was relatively easy. We're talking about just quantitative data and reading charts. This was actually, if you looked at the 2020 sample test question, this was kind of similar to that. In this example, they told you there's 2 high schools, one with 200 people, one with 221 people. And they wanted to know if one school's median was 6 and one was 7, which was which. What you have to remember is that the median value is the 50th percentile. And that if I can figure out where the 100th person in high school A falls, that's where the median falls. If I can find the 210th and 211th person, then that's where the median falls in high school B. So I went ahead and started to add up the total values, and you're getting close. Even if you're off by 1 or so, you're still fine. You can see in part A, or high school A, 46 plus 48. So less than 7 does not get you to 100. And so even if you rounded down on those things, you still don't, or rounded up, you still don't quite get there. It's less than 50, so when you add them together, both of them, you're going to be less than 50. So you have to go into the 7 to 10 bar range to find the median value for high school A. So you know that the median is more than 7. In high school B, you see that the median value falls in the second bar because you're over 100, it's up to 113 people. And so, right, so if you add 79 plus 34, you're going to get that 113. So I'm looking for the 110, 111th person. So they're going to fall in this range, which we know is less than 7 because the bar starts at 7, so it means the 7s are going to be in the next bar. So this one has a median value less than 7. This one has one that's at least 7 or more. So that allows me to find out that high school A has a median value of 7 and high school B has a median value of 6, if they are 6 and 7 appropriately, respectively. Okay, that's how I figured that out. In part B, they tell you that you had 18 additional teachers from high school. Let's see, high school. 18 additional teachers were not included in data from the 200 at high school A. The mean teaching of the years is 2.5 for all 18 new teachers. What's the new mean for all 218 teachers at the high school A? Well, we've done quite a few of these questions. I usually used it in like, if you had the average age of all 35 people in the room and somebody else walks in, what's the new average? Same principle. If you multiply the number times its average and add that together, it gets me the new total. If I were to add up all of the years together and then divide by the new total, 218, that gets me to the new average of 7.73. In part C, it's talking about, well, if you look at high school B, if the average is 8.2 and the standard deviation is 7.2, if one teacher selected from high school B, what's the probability that they would be within one standard deviation of the high school? Now, I wrote down a curve here. I'm not really going to use normal CDF in this case because I have the actual numbers up here. I can get a much more accurate representation. I'm not talking about first of all, it's not normal. So I really probably shouldn't have drawn the normality, the unimodal curve here. What I did want to do, I was doing this to get the actual value. So 8.2 plus 7.2 is 15.4, and 8.2 minus 7.2 is 1. So what I wanted to do up here from 1 all the way up to 15, not 16, right? I know it says 15.4, but you can't, they told you that the teaching year is recorded as an integer, so I'm going to have to round that down to just 15, right? So I wanted to count up how many people fell in these bars. And I approximated, or I got as close as I thought I could, and from these values, and I added them all up. And that tells me that there's 189 people out of the 221 that fell between 1 and 15 inclusively. And divide those two, and you're going to get approximately 85.52% of the people from high school B are within one standard deviation of the mean. I can't use a normal model here because, first of all, that is heavily skewed to the right. So not normal, can't use normal CDF. In fact, if I do, I'm going to get a really incorrect answer. It's like 68%, I think, right? 68, 95, 99.7. So don't use that. It's not normal. You know it's not normal just because of by looking at the picture. And that concludes question 5. Hopefully these weren't too complicated. There's a couple of tricky parts to some of these. I can see where you would go straight to the normal CDF on that last question and just not think about it. Hopefully this will kind of jog your memory with a lot of the stuff we did, especially with probability. So see you next time.